So the next step would be to create a transform that is able to take specific columns and reorganize them in a way that later a load is able to identify the data as a tree. So to build dimension hierarchy, for example.
Yeah.
So when I go to transforms, it's more or less the same steps, right mouse click, we create a new transform.
Ooh.
And you see you have a lot of transformations available here.
Yeah.
And because the transform tier we are now in, you are working with relational data only. Even if you want to create OLAP dimensions, elements, or cube data for cells, inside this tier, everything is relational. And therefore, the terms, the names of the transforms are a little bit abstract because you deal with fields, or you deal with joins of tables, or you deal with trees. And the trees, you need to create a tree. We talked about the customer dimension. The trees, they have extensions, FH, full hierarchy, or level element, numeric consolidated, or PC. So this means whatever source data is available, in which form the source data is available, I need to pick the appropriate tree transformation. In this case,
yeah, we had this in the parent-child relationship in my data, and so the tree PC would be the right choice here.
Exactly.
Okay, yeah.
So we choose the tree PC, give again a nice speaking name. We call it now again sales management analysis. We are in a transform. Actually, it's a PC transform, a parent-child transform, and this will be our customer tree.
Because it's for the customer
Correct.
dimension.
Yeah, for the customer dimension. And we hit OK, and now we are in the tree PC definition. Again, you need to define from where do we pull the data. So we pull the data from an extract. We only have the extract one created, the customer extract. So we select this one. And now the parent element, the child element, the weight, and maybe element type must be defined. So somewhere in your source data, you have columns now. We have a nice naming, right? For this this online course, we have nice namings. But imagine your data is not perfectly named like we have them named here. But you can select whatever you want. But you need to be sure that whatever you select has the correct information, right?
Yeah, of course.
So the source we are connecting to, the extract, gives us 5 columns. The parent column contains the parent information. The child column contains the child information. So whatever names you have in a different scenario, you need to be sure that you pick the right one. We can also tell the system that there's a weight and the element type. We don't have this, so this is an optional information. So we could everything will be numeric by default.
Okay. But I see down there is where the attributes are going to come into play, because I was already thinking, you didn't talk about the attributes yet, but I don't want to lose them.
Yeah, exactly. Yeah, and this is now the second part of the extract of the transform here. It's optional, but as you said, you have them inside. So I hit this little plus sign here to add a new setting here, where I can define with a double click. I have an attribute. I can name it. So this is more or less the same procedure we did in another lesson with the modeler. So you name it telephone, for example. And what is the type? So we can distinguish between numeric and string. In this case, even if it's a number, a telephone number, it might be a plus sign inside. So I stay with string, and then I say I define what is the source column to feed the appropriate attribute.
Makes sense.
In this case, the column with the telephone information. So I can apply, I can add another one because I saw that there's even a salesperson in your data. So we pull the salesperson also, string, and we say it's feeded by the salesperson, apply, and that's all. So we have defined from where we pull the data, which column contains the information we need to build a nice tree. So parent information, child information, weight if it's available, and we have attributes. So we save it and take a look to the flowchart. So we are connected to our Excel file. We extract from this particular Excel file the customer information only, and now we are in the 3PC, and we can also make a we can check the data preview here, and we see it looks more or less the same, but now it's the parent, child, and weight on top are really given by the system. So whatever column names you would have in your environment,
this is what it would look like now.
This is how it's being transformed. So from every kind of data you transform into this format. So
okay, and under the type, the N is for numeric?
Exactly, this is for numeric. Exactly. So we are ready to go for the last step.
Okay.
Because now we have technically a perfect tree defined. So every column has now a perfect definition, so that a load can read it exactly. What is the parent? What is the child? Do I have attributes? So we have to go to the next step.